All right, so now we talked about how to calculate creatinine clearance and how to adjust it for weight and all those stuff. So now in this video, I'm just going to be talking generally about what creatinine clearance is, why it's a good measure of renal function or kidney function, and the components of these formulas or the variables of these formulas and how they play a role. So let's first start off with what creatinine clearance is. So creatinine, so this is the CR part, is basically a byproduct of your body that usually your muscles give off, mainly when you're like kind of exercising or just normal day-to-day function. That gets almost 100% eliminated through your kidneys. So without giving a full-on long kidney or renal physiology lesson, your kidneys either have basically three functions. Either the first function is they do reabsorption. So basically they have things like, let's say, like salts, electrolytes in your kidneys, and they reabsorb it back into your blood. There's secretion, where they have things in your blood and they're putting it into the kidneys for it to eventually be peed out or excreted out. And third one is either excretion or elimination. I call it elimination, where basically your things that go into your kidney are coming out. So these are the three basic functions of the kidneys. Now, the good thing about creatinine, specifically creatinine, is that creatinine is mainly eliminated. So creatinine is mainly eliminated, meaning that there's not that much reabsorption, there's not that much secretion, which makes it a good physical measure of how well your kidneys are doing, because if it was getting reabsorbed, then you'll be excreting less. If it was getting secreted, you'll be excreting more than what you actually or your kidneys are working as. So because of that, because it's mainly eliminated, it's a good measure of how well your kidneys are doing. And that's where this variable comes into play, your serum creatinine. So generally speaking, serum creatinine's general range between 0.6 and 1.2, give or take 0.1 or 2 here and there, depending on the institution. But so this is basically how much serum creatinine or how much creatinine you have in your blood. So in your serum, which is like your blood, or how much creatinine you have, and that will eventually go into your kidneys, and that'll eventually be eliminated or excreted. So that's what this variable is explaining. Now let's go to age now. So why age? Well, age. The only reason of age is because your kidneys are one of the organs in your bodies in which, no matter how healthy you are or how sick you are, well, sick is obviously gets deteriorated faster, but no matter who you are, as you get older, your kidney function naturally declines. It's like you can't really prevent your kidneys from getting worse through time. They eventually get worse, and that's why we incorporate age. So the higher the age, so let's put over here age. So the higher the age, the lower the creatinine clearance is, which eventually means lower kidney function. So because age is over here and there's a minus sign, so it's 140 minus age, it makes sense. The higher age is, the higher this number is, and then when you subtract, this numerator gets smaller, and in turn, the creatinine clearance gets smaller. So that's what age is for in the creatinine clearance. Weight. Now, weight is basically a measure of, you're trying to assess how big the person is, or whether they're overweight or they're underweight, because there are like factors that affect, like let's say the excretion of creatinine in your body. So this is why it's a good measure of how big or small the person is. And in my previous videos, we talked about all the adjustments you make when your weight's too high or weight's too low. When your weight is really high over your ideal body weight, you use the adjusted body weight. Generally, people use the ideal body weight when they're like in normal range. And if you're severely underweight, you use their actual or total body weight. So that's basically these three variables that are in the creatinine clearance formula The 0.85, you times it by 0.85 when they're female. That's just some sort of factor you have to account, because females are generally presented as smaller physically, so you have to account for that. But overall, that's the formula, and those are the variables of the creatinine clearance formula, the Cock-Golf equation.